Screen is visible. Am I audible? My voice is audible.
Yes, sir.
Okay. Okay. So good afternoon to everybody. Now let us see the third type of gearbox. So this already we have seen. Constant mesh gearbox. Then how dog clutch is working and how power is transmitted from clutch shaft to the main shaft. That already we have seen. Then next part, that is Synchromesh gearbox. So that is again improved version with respect to the sliding mesh and the constant mesh. So in the Synchromesh gearbox, it is similar to the constant mesh gearbox. My voice is audible. My voice is audible. Sachin. My voice is audible.
Yes, sir.
Okay. So Synchromesh gearbox, it is similar to the constant mesh gearbox, wherein that synchronizing action, synchronizing of the speed, which is made by providing a synchronizing or the synchronizing unit or the synchronizer. So Synchromesh gearbox, it is an automotive system for shifting gear in which the gears revolve at the same speed, and so it can be shifted smoothly. So in this type of gearbox, a sliding synchronizing units are provided, and the speed of the driving and the driven gears will be the same, and then engagement can be made smoothly. So that additional device in the form of synchronizer unit instead of the dog clutch is provided in the Synchromesh gearbox. So in constant mesh gearbox, dog clutches are provided. So these are the dog clutches, D1 and the D2. This red one is the dog clutch, and instead of that dog clutch, a synchronizer unit is provided in case of the Synchromesh gearbox. So this type of gearbox is working so on the principle that Synchromesh gear devices, so two gears to be engaged are first brought into the frictional contact, and which equalizes their speed, after which they are engaged readily and smoothly. So in order to get the proper meshing, in order to avoid double declutching, which is required in case of the constant mesh gearbox. So in the Synchromesh gearbox, the gears or the two elements which are having different speeds. First, their speed is equalized, and after which they are engaged readily and smoothly. So that is the principle on which Synchromesh gearbox works. A synchronizing system is used for smooth meshing. So similar to the friction clutch, it is working, and that will provide smooth meshing and smooth shifting of the gears. So here, before going to see the actual working of the Synchromesh gearbox, first we are going to see how two elements are provided which works as a synchronizing unit in case of the Synchromesh gearbox. So here you can see this is the collar, this one is the gear wheel, one component it is shown here. It is also one component number 1 and component number 2. So what you are observing, so this component, let us consider it as a part of the gear wheel, and this component you can consider part which is connected to the main shaft. Now, to provide the speed of this gear wheel to this collar or this part which is attached to the main shaft or which is mounted on the main shaft, so we need to shift this collar part towards this part number 2. So it is mentioned as a 2. So just initially we are sliding with the help of, so this can be slide in this direction, and as this part, it is a convex in nature or some extrusion is provided, and here that cone is provided. So meshing between this gear wheel part with the collar part, so to this cavity, it is initially made just by shifting. So whatever friction between this part and the external surface of component number 2, that will act as a friction clutch, and whatever revolutions of this gear wheel part will be given to this collar part, and this you can see. So for sliding this, there is one arrangement, and with that arrangement we can put these two elements in contact. It is already rotating and it is mounted on the main shaft. So our aim is to rotate this, and simultaneously to have proper meshing, to have proper contact. This can be made with the help of the whatever frictional force which is acting between this 1 and 2. So this is the initial mechanism. Again, to give firm contact between collar and gear wheel, this is the additional tooths are provided, and those will in mesh with the cavities provided on the gear wheel. So this one is the part which is mounted on the main shaft, and this is the gear wheel which is rotating. So we want to transmit the rotation of gear wheel to this collar so that there will be rotation for the main shaft. Now in the constant mesh gearbox, what we have seen, there is drawback of double declutching because the speed of the dog clutch. So just I will add this image on the same slide so that you will get some idea, additional information. Okay, so here this is the dog clutch. So this one is the gear wheel and this is the dog clutch. So speed is different, and because there is difference in the speed, additional declutching is required, and that is called as a double declutching. Now in this case, or whatever previous slide, what we have seen, there is synchronization of the speeds. That is, in another word, we are going to equalize the speed first, and then there will be meshing. ह्या केस मध्ये ब्ल्यू गिअर आहे, याचा स्पीड, आणि हा रेड डॉग क्लच आहे, याचा स्पीड हे डिफरंट आहे. आणि आपण जर मेश करायचा प्रयत्न केला तर इन सिंगल स्ट्रोक it is not possible whenever shifting the transmission from top gear to the bottom gear. Instead of this, there is another improvement which has been provided in the Synchromesh gearbox. First, we are equalizing. ह्या दोनचा स्पीड पहिल्यांदा इक्वल करायचा. तर ते इक्वल करण्यासाठी Synchromesh gearbox मध्ये काय वापरले? So such male and female cone. So like that, this is the collar and this one is the gear wheel. हा part आहे, हा it is in mesh with this collar, and that will equalize the speed. And speed equal झाल्यानंतर we are going to have meshing between these two components. समजा याचा स्पीड आहे 100 rpm आणि याचा स्पीड आहे 80 rpm. तर हे 100 rpm and हे at 80 rpm. There is a difference in the speed. Now, if we are going to shift this collar towards this, त्यानंतर हे 100 rpm ह्या कॉलरला तेच स्पीड असणार. How to get that speed? So this surface and this surface will be in contact and they will act as a friction clutch and speed will be equalized. So that action is called as a synchronizing, and afterwards there will be meshing between these two components, and that action is called as a synchronizing. So you can see here. So here it is clearly mentioned. So I will read once again. The Synchromesh gear devices work on the principle that two gears to be engaged are first brought into frictional contact, which equalizes their speed, after which they are engaged readily and smoothly. So this one is the principle of operation of the Synchromesh gearbox. Okay, so here you can see this difference. We have seen 80 and 100. Then here you can see the permanent engagement with respect to this collar and the gear wheel. This is gear wheel and this one is the collar. Now togetherly they are rotating as there is firm engagement, and this is similar to the positive clutch. Okay, now in this case collar and gear wheel revolving together. So similar to the friction clutch. So what we have seen, one component is rotating, that is flywheel is rotating, and those rotations are transferred to the clutch just by putting those two components together. The same way here, this collar and gear wheels revolving together. Okay. Now you can see this. So this one is clutch shaft. Am I audible? Am I audible? My voice is audible. Somebody should respond. Jagdale, my voice is audible?
Yes, sir.
Okay. So this is Synchromesh Gearbox, a schematic layout. One sectional view is shown. First of all, we have to see the construction. This one is the clutch shaft. This is gear on the clutch shaft. This is lay shaft. And this one is the main shaft. Now we are going to see how many gears and which type of gears are provided. So this is a helical gear which is mounted on the clutch shaft. Again, this is helical. That means this should be the helical, as these are having meshing between them. So this is the clutch gear, and these four are the gears which are fixed on the lay shaft, and these gears are in mesh with the gears on the main shaft. So this is one gear, this one is second, and this one is the third. So 3 gear wheels are provided on the main shaft. So these 3 gears are utilized to get 3 forward and 1 reverse speed. So here you can see here, this one is called as a synchronizer unit or the synchronizer. This is also the synchronizer. So for getting 2 gear ratios, so previously we have seen 1 dog clutch is used. In the same way, to get 2 gear ratios, 1 synchronizer unit is used. So this one is the S1, first synchronizer unit. This is S2, second synchronizer unit. So this unit will provide 1 reverse and 1 forward speed, and here 2 forward speed will be provided. So you can see or relate the cone and collar. So whatever image we have seen in this slide, so just I will copy it. Okay, so here you can see this is this component and this one. Milin लक्षात आलं का? How I am relating the component, that collar and the gear wheel?
Yes, sir.
Okay, so this one is the collar. You can see only this portion. Okay. So just by providing one collar for this synchronizer unit and one such surface similar to this on the gear wheel, or which can be attached to the gear wheel, so we can have synchronizing action. So just by sliding this collar towards this gear wheel, so whatever frictional force available in between these two surfaces, and that frictional force will equalize the speed once this collar or synchronizer unit is going to shift in this direction. So already we have seen how rotations or power is transmitted from the clutch gear. This one is the clutch gear, this is the lay shaft gears. If this is rotating, all the gears on the lay shaft are going to rotate, and as these gears are in mesh with the gears on the main shaft, all the gears on the main shaft, they are also going to be rotate, but power is not transmitted. Why? So you can see all these gears are going to rotate, which are mounted on the main shaft. This will rotate, this will rotate, this will rotate, and this synchronizer unit, it is splined to the main shaft. इथं लक्ष द्या. Here black portion indicate that this gear is mounted on main shaft using bearing. This gear is mounted on the main shaft using bearing. This gear is mounted on the main shaft using bearing. So they are free to rotate. This is free to rotate. This is free to rotate. And here we are not observing any such black portion that indicates that these gears are firmly attached to the lay shaft or firmly mounted on the lay shaft. Once this gear is going to rotate, all the gears are rotating with the same speed, and now rotations are given to the gears on the main shaft, but power is not transmitted to this main shaft. To get power or rotation or the transmission of rotation from lay shaft to the main shaft, there is need of connection between this synchronizer unit and the gear wheels mounted on the main shaft. How to get the connection between these two? These synchronizer units are shifted based on which transmission ratio is required. So for example, we can take first gear. So I will show how it takes place. Okay. Now this clutch gear is rotating, then power is transmitted like this. Now power is available to this gear. Now to have first gear, if we are going to shift this synchronizer unit in this direction, there is contact between these two surfaces, and whatever speed of this gear is given to this synchronizer unit, and ultimately as this synchronizer unit is splined to the main shaft, and now power is transmitted to this main shaft, and now it is rotating. In the same way, this is about the first gear. In the similar manner, we can have another, that is the second gear. This way. So we can have shifting of synchronizer unit in this direction. You will get second gear, here third gear, and now how to get the top speed? Just by shifting this synchronizer unit towards left side, there will be contact between these two surfaces, and whatever speed of clutch shaft, that is given to this main shaft, and that is nothing but the top speed. That is nothing but the top speed. Additionally, you can see this synchromesh unit or the synchronizer. You can check. So working of synchromesh gearbox that we have seen. Now just this is gear wheel. This one is gear wheel cone. This one is internal cone. So whatever two surfaces and the friction between these two surfaces after shifting of this synchronizer unit in this direction. So you can check there is contact, and this whatever external ring is there, it is in contact with the teeth provided on this gear wheel cone, and now power is transmitted from this gear wheel to this synchronizer unit and finally to the main shaft. So this is the engaged position of synchromesh unit or the synchronizer. Understood? मिलिंद समझला?
Yes, sir.
Okay. Then next part, that is overdrive. So for that, so please give me 1 minute. Please give me 1 minute. Okay, screen is visible.
Yes, sir. Visible.
Okay, so I have added some of the part so that you will understand. So some of the information I have added. So basically overdrive, with the name itself, you can understand that in automobile there is one device by means of which we can get additional speed without spending extra fuel or without consumption of more fuel. So here we can make use of epicyclic gear trains, and with that epicyclic gear train we can have a device which can used to step up the gear ratio, and that device is called as an overdrive. So overdrive is a device to step up the gear ratio in the car. So this overdrive, so basically it is a component which is fitted in the transmission system, and it is after the transmission or the gearbox. So just I will draw, so you can check. This one is the engine, here it is clutch, here it is gearbox, or I will call it as a, we can call it as a transmission or transmission box, and here it is propeller shaft, and in between these two there is one device, and that is called as a overdrive. So engine is rotating at certain speed, and that speed via the clutch it is given to the gearbox, and accordingly in accordance to the torque requirement, a particular speed will be obtained at the output shaft of the gearbox. And now, for example, output shaft of the gearbox, it is rotating with 100 RPM. And if this overdrive is not included, then the propeller shaft will rotate with the same speed. And instead of this, if we are going to provide a unit which includes epicyclic gear train, then it is possible to increase this 100 RPM to 120 RPM. So 100 RPM speed can be increased up to 120 RPM. So how it is possible? So it is possible with the help of the epicyclic gear train. So generally this device, it is fitted in between transmission and the propeller shaft. So you should remember this. So afterwards, I will take what is epicyclic gear trains. Already we have seen in the theory of machine. So epicyclic gear train in the theory of machine, and the same can be utilized in this overdrive. So this enables high cruising speed to attain with comparatively low engine speed. In other words, suppose on the level road or on a national highway, so having good condition or good surface, so once it will reach certain speed, so whatever fuel requirement will be the same. Again, engine is running at some constant speed. Thereafter, there is no considerable change in the road condition. So what will be there? So whatever torque requirement will be the same. So once the vehicle will reach a certain speed, and that to some constant vehicle speed, then the vehicle can put into certain transmission mode, and that will enable to overdrive the propeller shaft than whatever speed of the output shaft of the gearbox. So gearbox just output shaft speed 100 rpm आहे, तर ते 100 rpm चे 125 rpm करण्यासाठी epicyclic gear trainचा उपयोग केला जाऊ शकतो, and that can be done once there will be no change in the torque requirement. That means constant engine speed. So speed can be increased up to 20 to 25% on long journey. And what are the advantages with respect to this? So the results in less wear of the engine and also decreases vibration and the noise. So basically it will save the fuel. So engine is running for 6,000 rpm to achieve 80 kilometers per hour. Now there is no change in the engine speed, but we can increase the speed from 80 kilometers per hour. So that can be made with the help of this overdrive. So this is generally fitted on the top gear. So sometimes you might have heard that it is having single top. Some vehicle are having double top. What it indicates? So suppose a vehicle with 5 speed forward and 1 reverse. In that case, a fifth gear can be considered, which can be worked with the help of this overdrive. And once that fourth gear transmission is running, and now if there is no change, we can engage the vehicle into the top gear, and that is called as a first stop, or sometimes the gear in which we can move the vehicle at high speed. That gear we can call it as a top gear. So you can see this. So such overdrive can be fitted only on the top gear, with some of the exceptions. In some sports cars, overdrives are also fitted on gears other than the top gear, and that will enable to make availability of increased torque ratios. So for example, when overdrive is fitted on top, the third and second gear, so 7 forward speed and torque ratios are available. So if now you can see this top, third, and second. So we can have 7 forward speed or torque ratios. So it can be operated with the help of manual effort, or it is also operated automatically at predetermined speed. So after 80 kilometers per hour, once there is no need to change the torque, we can have engagement of this overdrive to save the fuel and to cover the more distance. So there is some predetermined values, so after which we can have operation of this overdrive. Now let us see the construction. So this is the schematic diagram of the overdrive. So this is input shaft and gearbox. This is also called as the gearbox output shaft. So previously I have shown, so just this is gearbox. And here it is propeller shaft. So this shaft and this is connected to the propeller shaft. So this is in between the gearbox and the propeller shaft. So this overdrive consists of a pair of planetary gearbox. So you can see this one is the sun gear, this is the sun gear, this is planet pinion, this one is planet pinion, this one is the carrier, and this is the ring gear. So generally such combination is used and which is mounted on the input shaft of this overdrive assembly, and this planet gear is in mesh with a casing which is mounted, which is connected to the output shaft, and this unit is called as a freewheel clutch. So this one is the fly, this is flying to the input shaft of this overdrive assembly. Just wait a minute, wait for a minute, I will show. Million screen is visible?
Yes, sir.
Okay. So such epicyclic gear train. So you can see this one is the ring gear. This one is sun gear, so internal one, and these three which are placed with the help of this arm, or we can call it as a carrier. So such, with the help of such arrangement, we can have overdrive of this, whatever speed of this input shaft that can be increased here with the help of this arrangement. So now in this case, how this sun gear is mounted on the main shaft, how this carrier, how this freewheel clutch works, and how power is transmitted to this output shaft. So here, so as already you know, in the epicyclic gear train, and to find out motion of the particular element, so I will give one more example. So this one is the sun gear. Simply I will write yes. This is planet gear. This one is planet gear. And this one is the ring gear. Okay. So you can relate this. Okay. And this one is sun gear. Right. So this sun gear is mounted on this input shaft. Mounted on input shaft. So you might have remembered that for one revolution of sun gear, what will be the revolution of the ring gear? Again, for one revolution of the arc, what will be the revolution of the ring gear? So in case of epicyclic gear train, and to find the speed of a particular gear, two elements are important. So which are those two elements? Either gear and the arm. So arm along with the one gear. So we need to fix the arm and rotate a particular convenient gear, and accordingly whatever revolution of those elements relative to that fixed arm, that we are defining in the table, and afterwards what are the revolution of each element along with revolution of the arm or the cage, that we are finding. So based on that, first of all, if you are going to consider this sun gear, and here you can see it is free to rotate. So first of all, see how power is transmitted. So when this input shaft will rotate, this cage is going to rotate. As cage is going to rotate, the pinion gear will rotate in certain direction, and accordingly this output shaft is going to be rotated. Now here, what will be the condition? So a case study I will tell. So sun gear is fixed. So actually we are tabulating the data just by assuming arm is fixed. Gear A rotates through one revolution, that is one revolution in anti-clockwise direction. In the same way, first of all, we are going to tabulate the data, and afterwards for the condition, for the particular condition, as our aim is to rotate this output shaft, here sun gear should be fixed. When sun gear is fixed, then cage will rotate through the power from this input shaft which one is the output shaft of the gearbox. So this will rotate. So again, this is the condition for the sun gear. Then additional condition will be there based on if arm is fixed and sun gear will rotate. Which gear we are going to lock? Based on that, a particular speed can be attained. Particular speed can be attained. So based on whether cage is locked, whether sun gear is locked, that is fixed. So we can get the speed of this output shaft, and which is connected to the propeller shaft. So in tomorrow's lecture, I will take one example how speed is increased so that you will understand the working of the overdrive. So just I'm stopping here. Wait for a minute. I will take attendance.